Greetings and welcome, friends. Mr. Waddy here. We're taking a look at last night's quest, page 117, Big Ideas Math. We've got a different batch of problems. We're talking about linear functions still. And it says this. Here we go. So these were kind of from example 3 on. If you want to look through your book or look at my lesson video, those were the examples that this was kind of covering. So it says, determine whether the equation represents a linear or non-linear function. Explain. You've got some explaining to do. So let's see. We were told that linear functions could be written as y equals mx plus b, in which, there I am, m and b represent just plain old integers or numbers. I'll just write numbers. And y and x represent variables, right? Variables. Okay, so here's the question. Linear or non-linear? Non-linear would be any function that is not a line. And let's see. So I've got y equals x squared plus 13. Kind of looks almost like this, except what's the problem right here? This little invisible exponent here is actually an invisible 1 for a linear function. And here I've got a 2, and that is not ever going to be able to be written as a y equals mx plus b. So this is non-linear. And actually, if you wanted to know what the graph of this looked like, it would look something like this. This is a quadratic equation. Don't worry about that. We'll talk much more about them later. And the graph would be a parabola. Oddly enough, I'll tell you this. That value is 0, 13, which you guys probably could have figured out if you made a table of values, just input some x's, tell me the y's, picked some points, you would have been able to figure something like that out. Now, I picked 21 because this one, it's got a lot of flash going on here. It's got a lot of pizzazz. I was going to say pedazzle, but I don't think that's a thing. But notice I actually do have the ability of rewriting this in this form if I solve for y. So let me actually solve for y. So then I can know. Solve for y. So the first thing I would do if I'm solving for y is to get y by itself. It's being multiplied by this fraction, and it's being added by 2. So I've got to get things away from it. So I would subtract 2 from both sides. Notice I'm lining this up under its like term. These guys are friends. Friendship. How wonderful. So I'd have 1/6 y is equal to 3x. And let's see, 4 minus 2 is positive 2, so plus 2. All right, how could I get rid of a 1/6 in front of y? It's being multiplied. So you might think, well, I guess that means I have to divide everybody by 1/6, which you could have done it that way or this way. But that is somewhat of a terrifying notion. Do you guys remember the easier way to deal with a fraction in front of a variable? I multiply by what? Do you remember? Yeah, flip it like this, right? Yeah. So 1/6 is now 6 over 1. That's called the reciprocal. Math on the street, sometimes I call that refliprical. Am I right? You guys get it. You guys get me. And so I'd have to multiply both sides by 6 over 1. Notice the convenience of doing so. Swipe. Those guys cancel out. I do, in fact, get y by itself. But does this become anything that could be written like that? Well, let's distribute. Let's see. 6 over 1 is the same as 6. 6 times 3x is 18x, and 6 times 2 is plus 12. And that, my friends, does look like that, right? That's an x to the first. The variable's not somehow in the denominator. There's no weird square roots or exponents. This, my friend, is a linear function. Okay? Linear function. And this one was non-linear. Okay, let's keep moving. I said I was going to do this fast, but I don't think I'm doing a good job at that. I'm trying. Let's see, find the domain of the function represented by the graph. Let's see, so domain are the possible x values. So this would be, the domain is the set of, let's see, these points exist right here, and right here. So my domain appears to be, see, what are these counting by? What are each of these grid lines count as? Yeah, it looks like it's counted by 2. So it looks like 2, 4, and 6 are my possible input values. Let's talk about range. Let's see, range. Looks like it shows up here on the y-axis here, right? If I'm just kind of mapping these across, you guys see that, and there. So my range happens to be 6, 12, and 18. Oh, getting better at my curly brackets. And then they asked, is it discrete or continuous? This is discrete because these points are disconnected from one another, right? They're just kind of like plopping a bunch of numbers there. So that's kind of my explanation. Let's take a look at this one real quick. The domain. If I was to map all of these points down to the x-axis, if I was to step on this and squish it down, the possible x values would go from here to here, including those endpoints. So the domain, we'll say, is the set of all x, vertical line, like an absolute value bar, such that x is between 0 and 7. And the way we represent that is 0 is less than or equal to x is less than or equal to 7. All right, using kind of our compound inequality from back in the day. Good times. Let's see, for the range, if I was to smush this sideways, notice everything would actually fit between here and here. All right, so the possible output values are the set of all y such that y is between 20 and 25. So I'm going to say 20 is less than or equal to y is less than or equal to 25. And the question is this, discrete or continuous? Well, all of the solutions are connected, so it's continuous. Connected, continuous. Nope. Continuous. Yeah, I like it. All right, let's see, one more problem. Determine whether the domain is discrete or continuous. Now, this required you to analyze this part right here. This was really the only thing we had to consider. Right there. It's asking, is it discrete or continuous? Now, maybe if you watch trees grow in Minecraft, you'll notice that their height just suddenly like jumps from, 1 block to like 20 blocks or something like that. Probably not that high, more like 9 to 15, right? And that's just like an instantaneous jump. But trees in real life, in our universe, the non-Minecraft universe, which I understand is not nearly as exciting for you kids these days, but nonetheless, trees grow slowly over time. This would be a continuous function. All right. Because trees grow slowly. They don't suddenly jump in height. So trees grow slowly. All right. Their height is continuous as they grow. As 0, right? So tree height is something that is continuous as a result. All right. Well, thanks for watching, Internet friends. Have a good day, Internet friends.